Okay, so hello everyone. This is going to be a continuation of section 5.3, probabilities using counting methods. So we have example number 4 here. 3 prizes are awarded in a raffle during a halftime show at a school basketball game. Ben, Janelle, and James and 17 others have 1 ticket each. So if the raffle has a first, second, and third prize, we are to determine the probability that Ben wins the first prize, Janelle wins the second prize, and James wins the third prize. Okay, so we're going to simplify the question a little bit. We're just going to write it as the probability of event A, where A is Ben winning the first prize, Janelle winning the second prize, and James winning the third prize. We're not going to write that whole thing out. So obviously there's only one prize for first place and one Ben, one Janelle to a second place prize, and James getting a third prize, so that's one choose one as well. And that's first, second, and third. And if you think about it, there's only exactly one outcome that's what we want. So it makes sense that we just have 1 times 1 times 1, basically, in this case. Let's see here. Okay, so the denominator is going to be, there are 20 students in total. And the order, of course, matters because first, second, and third prizes are not the same. So even with Ben, Janelle, and James, if they win the prizes in different order, that's a different outcome already. So order definitely does matter here. So we're going to have 20p3. And again, to indicate why that is because order matters. From there, this is some calculator work. 1 times 1 times 1, or 1 choose 1 is 1, of course. So we just have 1 for numerator. And 20p3 is 6,840. So for this question, we'll not be writing it as a decimal or a percent because the question asks for an exact value. So we're just going to leave it as a fraction. Okay, so if instead of first, second, and third prizes, them being different, if the raffle just has 3 identical prizes, we are to determine if the probability that Ben, Janelle, and James just wins the prizes. Okay, so let's see, probability of B. So because the 3 prizes are identical, the order that they win in doesn't matter anymore. So we just have 3 people, and we're going to choose all 3 of them to win the prizes. So 3C3. And likewise, for the sample space, since the order doesn't matter, we just have 20C3. Again, that's because order does not matter. Okay, so once you've figured that out, 3C3, that will give you 1. And then 20C3 will be 1140. So that's it. We're going to leave that one as an exact value as well. So let's move on to the next part. 3 people are randomly chosen to form a fellowship of 14 to be president, treasurer, and secretary. What is the probability that Frank, Sam, and Aaron will be once chosen? Okay, so let's write that as probability of C, where C describes the event. Now, president, treasurer, and secretary are different posts, so the order matters. It will be different if Sam is the president versus if Aaron was the president versus if Frank was the president, and likewise for the other 2 roles of treasurer and secretary. So we will have 3p3. We have 3 people. We're going to choose all 3 of them, but the order matters, so it's 3p3. Alternatively, you can think of it as 3 factorial, right? 3 different people can be president. The 2 people left over can be treasurer, and then the last person left will be the secretary. So there's 6 different ways for that to happen. Of course, that's 3 factorial. And we'll divide by the sample space, and that sample space, of course, is any of the 14 people, and we're going to pick 3 of them to be president, treasurer, secretary. So, of course, the order mattered there as well. So 3p3 is 3 factorial, which is 6. And this will be divided by 14p3, which is 2184, sorry. And of course, you can just use the calculator to figure that out. And this one, we're going to write it as a percent. So it will be just above 1/4% chance of that happening. Not particularly likely. Okay, so that's how there's examples of questions where sometimes the order don't matter, and then sometimes the order does matter, and you are going to have to distinguish when does it matter, when does it not matter. Moving on. So example number 5, and these are questions about just using the factorial notation more than anything else. It says here there's an online game that's password protected, 2 capital letters followed by 3 digits. That's the format of passwords. Okay. So probability that password contain S and Q. So let's look at that together. So probability A, again, where A describes the event. So if it has to contain the letters S and Q, there's only 2 arrangements of that. Really, it's either SQ or QS, right? And then the 3 digits doesn't have any restrictions, so you can have anywhere from 0 to 9, anywhere from 0 to 9, anywhere from 0 to 9. So those are 10 digits each. And we divide by the sample space, which is all the possible passwords. So we have 26 letters to choose from the first letter, 26 letters to choose from the second letter, and then 10, 10, and 10 for the 3 digits. Okay, so you should notice that the 10s will eliminate each other, so you don't have to worry about those. 2 factorial, of course, is 2, and then 26 times 26 is 676. And then you can, of course, write this as a percent. That will be 0.296%. Simply divide and then multiply by 100 to get the percentage probability. Okay. Next one is similar. Pin number, consists of 4 digit. So repeats are allowed. That's good. And then what is the probability that the code begins and ends with the digit 5? So let's look at that together. Probability of B. So there's only 1 5, so there's only one choice of the first digit, and then any 2 digits in the middle, and then it has to be a 5 again at the end. So these are the 2 5s, so we're going to write choose 5 here. And then compare that to the sample space, which is really any digit. So that will be 10 choices, 10 choices, 10 choices, 10 choices. And if you multiply the numerator out, you get 100. Denominator will give you 10,000. And so that will work out to be 1%. Now for the next part, we haven't looked at permutations involving repeated objects just yet. That's what these 2 last examples will allow us to examine. Let's look at number 6. A computer has rearranged all the letters in the word Surrey into every possible order. So we will pick a random one, and what's the probability that the chosen arrangement begins with 2 R's? Okay, so probability R, R, and then the other 4 letters. The other 4 letters in order would be S, U, E, and Y. Okay. Now, there's only one way to write RR So that's 1. If we can have any arrangement of S, U, E, and Y, that would be 4 factorial arrangements. You have 4 different letters for the first spot, 3 for the second spot, 2 for the third spot, and finally 1 for the last spot. So that's 4 factorial, of course. And we're going to divide by the number of possible outcomes in the sample space. There are 6 letters in Surrey and 2 R's. So if you think about permutations of repeated objects, we will take the total and then divide it by the 2 R's repeating. Oh, sorry. Repeat. So once we have that, 4 factorial is 24. 6 factorial is 720 divided by 2 is 360. And you can convert this into a percentage as well. This would be 6.67%. Okay, finally, the last one. The last one, we're looking at the word Saskatchewan. And so the idea here is we're going to randomize the letters in the word Saskatchewan and then see what's the probability that we just like put it all back together correctly. So that's what we're doing. So let's see. Saskatchewan has 3, 6, 9, and 12. 12 letters. Now, of which 2 of them are A's. Oh, sorry, 3 of them are A's. Oh, but there are 2 S's, right? That's what I meant to write. 2 S's and 3 A's. So the probability, I think this is about Sally winning a car if the randomly arranged letters spell Saskatchewan correctly. So probability of a win. Of course, you can only spell Saskatchewan correctly in one way. So that's 1. And the denominator will be 12 factorial because there are 12 letters in the word Saskatchewan. There are 2 S's, so 2 factorial, and 3 A's, 3 factorial. And of course, you can evaluate that number. So the numerator will just be 1, so that's easy. And it turns out 12 factorial divided by 2 factorial, 3 factorial is this number. All right, so if you think about the winning of a car, this is really unlikely to happen. And so that's it. So we have looked at using various counting methods for probability, including permutations, combinations, permutations with repeated objects, and just factorials. Okay, and that's it for today. Thank you for listening.